done that problem yet. Okay, so take a look at this problem here. You have log base 232, log base 2, a bunch of other junk as well. So all you're doing is you're setting the other side equal to like a variable. Like let's say call this x. Oh, geez. And you're gonna say 32 equals 2 to the x power.
Sure, you're all right. So just the Commanders were going to beat the Buccaneers.
Yes, you did tell me that, but you were wrong about the Packers and you're wrong about but the other Rams or Vikings. Okay.
I was biased.
Yeah. Well, anyway, guys, let's not get distracted. We can talk sports after I finish. Without Jimmy here. Okay. Yes, Gabe. Sure, go. Yeah. Fine. Okay, let's move on. Oh, page 13 of the notes. No worries. All right, let's move on to the next one. So 1/2 will equal 2 to the x power. What would x equal in this case? Perfect. Good. Okay, let's go through. So as you get the hang of this, you don't really necessarily need to keep doing this writing of equations and solving for x, but you can if you want. What do you think c is going to equal? 2. Yep. That's because 4 equals 2 squared. 4 equals 4. We know this. Okay, we'll come back to D in a moment. What do you think I'm going to put in the question mark for E? 8, yes. How about for, that one's a little tricky. What do you think for, no. Root 2, yes, good, yes. Because x is going to equal 2 to the 1/2 power. Ah, geez. Or root 2. Okay, what do you think about for G? Yep, -4. And lastly, for H, 2 to the 0 power equals x will be 1. Now, I didn't do D yet, because D is a funny situation. Yeah, that's going to be undefined. That's a proper way of expressing the answer for that one. That's because 0 equals 2 to the x. Can't happen. Because you can't multiply 2 a bunch of times to get 0. That's just impossible. Okay. Let's move on to 568. First off, we want to figure out what the equation is, and then fill out the table, and then answer C and D. So if we look at, yeah, if we look at here, like, when, think of this as y, by the way, g of x. Let's just call it y. So x is 8, y is 3, or x is half, y is -1. It's gonna be a log equation, just so you know. Log. It's a long day, so I'm fixing up my words. So a logarithm, there we go. So what do you think the base is for this log? Yep, yep. Yeah, because if you do log base 2, 8, you get 3. Because remember, the whole point of a log is really to figure out what the missing exponent is. That's really the whole point. So 2 to 3. I would expect no pass. So the 3 goes here, and the 8 goes here. Or you can rewrite it like this. You can rewrite where x is the output of one. In this case, you go 3 and then 8. 8 equals 2 cubed. Yeah, and also it's consistent with 2 and 1/2 and -1. If I plug in -1 for y, x will be 1/2. That works. So that's gonna be the pattern here. So if I kind of continue doing this, let's actually focus on this equation. That's kind of a little easier to focus on. And let x be the output. And let y be the input. Okay. So for example, if I were to say 30, let x equal 32, 32 equals 2 to what power? 5. 1 equals 2 to what power, guys? 0. 16 equals 2 to what power? 4. Michelle, you're on fire today. Look at you. Okay, guys, quiet. 4 equals 2 to what power? 2. Okay, let's stop because I feel like everyone's focused. Good girls, I need you to focus, please. Thanks. All right, let's stop because I don't want to get too carried away. So we first identified that this is a log equation. Okay, that's because if I let x be 8 and y be 3, I have this equation here. This equation can be rewritten as x equals 2 to the y, because log base 2x equals y, the same thing as x equals 2 to the y power. So if I let y be my input, 2 cubed is 8. 2 to the 1 is 1/2. That makes sense, right? So it's just kind of a reverse situation. So with that in mind, 2 to the x equals 32, my input must be 5. If I want my output to be 1, my input has to be 0. If I want my output to be 16, I want my input to be 4. If I want my output to be 4, I want my input to be 2, because 2 squared is 4. 3 is a weird one. Let's just cross that one off for now. And let's cross off 0.2 as well. Okay, for 64, let me clear some space here. What if 2 to the y equals 64? 6, yeah, totally 100%. 2 to what power equals 2? 1. Can 2 to the y power equal 0? Nope. So I'm gonna say it's undefined. That's kind of hard to read. Sorry about that. Oh, thanks, Jimmy. It's undefined. Okay. How about 2 to negative 2? Can 2 to y equal -1? Well, can you multiply 2 a bunch of times to make it negative?
No.
We can't, right? So that's undefined also. But oh, were you doing 0.25? I'm sorry. Yes, that you're correct. That is -2. Sorry about that. Okay. This one will be 1/2. And this one will be -3. Because they're weird decimals. I didn't feel like doing it.
How do we know, like, these, I understand the output, but how do we know these outputs?
So when the ones that were given, if I did 2 to the x, 2 to the y power equals x, it would be consistent with what's given. If I raise 2 to the 3 power, I get 8, or 2 to the 1 power, I get 1. So instead of thinking of x, as input, think as the output, and y is input. That's how logs work. It's like an exponential equation with x and y switched. That's what I want to think of it. And why was it difficult to think of an output or input? Sorry, an output for the input of 0, -1. That's because 2 to the y power cannot equal 0 or -1. Just can't happen. And then finally, for D, so in between what two whole numbers would y equal? Would you say? Do you guys see why y has to be between 4 and 5? Because what's 2 to the 4th power? 16. What's 2 to the 5th power? So at least I know y is to be between these two numbers. Now, if it is asked for nearest 100, you have to use a calculator. Now, this is where I want you guys to get your calculators out. I want to show you how to do this in the calculator. So if you have a calculator, please get it out. If you don't, you look off a group number or you borrow one. But I want to show you how to do this in the calculator. I'm going to show you right now. That's what I'm doing right now. That's why I asked him to get him out. Dude, don't you have to leave?
Can I listen to you and say how to use this calculator real quick?
Sure. But what time's the game? Was it 2 o'clock early dismissal or 2:05 or? Oh, you got. Oh, you're okay then. Okay. Okay, let me clear the screen. All right, really simple. Guys, quiet, please. Thank you. What you want to do? Oh, geez. Hold on. Here we go. I keep saying that. I don't know why. All right. Alpha. Quiet, please. Thank you. Alpha window option 5. That's how you can locate it. That's common log. That's a different thing. We won't do that today. So alpha is green. Windows in the top row. Option 5. And then you're gonna do, because 2 to the y.
Thanks, mystery.
All right, see you later. Welcome. Good luck to you. That's the button you press in the calculator. So you're gonna rewrite it like this. That's how you locate the log. And then you type in the numbers. So okay, let's back up, guys, because we need to know what we're actually doing. So for part D, 2 to the y equals 25, right? That's what it's asking us to do. Or log base 2 of 25. That's what I have to do. So I put in a 2 here and a 25 in size. 2 is my base, 25 is my input. My output's 4.64 or 4.64 is good enough. I'll tell you, this case is 2 because of 100th. So 4.64. We're cool. All right. Okie dokie. Let's keep moving. $4.64. Yeah, sorry, I'll undo. My apologies. Okay. So I just want to make sure we kind of see numerically what's happening, how to do this in the calculator, understand why can't equal 0, -1, or negative numbers. Let's not do 5, 6, 9 because it's kind of repetitive. And graphically speaking, well, I'll just do it really quick with you guys. Just copy what I do. I'll do it really fast. So we're using log base 5. So now, but I've hit the math button and scroll down to, I think, option 8 or 9. No, A, sorry. You can locate it there as well. Okay. You can locate it there as well. So if I were to, guys, quiet. Go to math and then scroll down, or do alpha window, either way.
Alpha window options.
Option 5.
Show it again.
Sure. Alpha window option 5. And it's recorded, guys. You guys can watch the recording. It's recorded. All right. So, guys, quiet, please. Thank you. Log base 5 of 2 is 0.431. So this right here is 0.431. Okay. Because you're told that. Yeah, no worries. All right. If I rinse and repeat. Rinse and repeat. You get these other decimal answers. So here's what's happening. Okay. Emmy, I need you to focus. Thanks. All right, it's okay. I forgive you, but we just gotta keep moving. All right. He's not forgiving. Oh, my laptop's dying. Okay. What was that? Wait for which one? Sorry, 0.68. Oh no, I'm seeing a little bit of it right now. Just a little bit. All right. So by plugging these numbers into the calculator, here's what's happening. If you plug in 1/5, okay, guys, I need you to be quiet. Thank you. I'm still talking. I know it's Wednesday afternoon. I get it, but let's just finish strong here. So If I plug in 1/5, I get -1. If I plug in 0, sorry, I plug in 1, I get 0. If I plug in 2, I get 0.431. So it's slowly increasing. If I plug in more fractions, it becomes more negative. Like I think it's -2 for this one. And it's often really hard to plot 1/25 for x. But you can see when it's hugging the x-axis, it's sorry, when it's hugging the y-axis, the graph is getting more negative. And that's a graph of a log. How does it compare to y equals 5 to the x, which is this? It's reflective about y equals x. So it's the inverses of each other. That's what's happened, the inverses of each other. So I just want to show you the graph of it because we will explore these graphs later. I don't feel like filling out the rest because it just becomes kind of redundant after a while. It's just much decimals. What's
So
happening?
it's log 5 is taking that number and multiplying it by and putting it.
So what you do is you're doing 5 some power equaling each of these. So like 5 raised to 0.683 equals 3, 5 raised to 0.61 equals 4, 5 raised to 0.431 power equals 2, 5 raised to 1.11 power equals 6.
Oh.
The second row are your exponents.
Uh,
The first row are the outputs.
All right, let's do the next page. So we got about maybe 5 to 10 more minutes. We're done. You guys can work on homework. All right. So for 571, and I'll need to charge my laptop so it doesn't die on us. All right, for 571, you're asked to find the inverse and then isolate y. We're just doing page 15. Doing what? What's that? I don't know. Oh, this right here? That's just a fun game we'll play. I don't know, or a table, or I don't know, kind of a activity. All right. So when you switch x and y, then you want to solve for y afterwards. All right. Okay, so we're switching x and y. Emmy. I have to move you. I think I have to move you guys next week. All right. I don't know. Let's see. Really? Oh, okay. Let's see. Yeah, I do know that. Yeah, of course. Okay. But you guys are friends too. Are you comfortable? We are? Okay. All right. Anyway, you see what happened here? So after I switch x and y, okay, do a swap. Your goal is to get this variable by itself. Because it's a log equation, to undo the log, you have to take the base and raise it to the other side, right? That's what we talked about before. So y equals 9x. That's going to be the inverse of a. So let me set up B, C, D and have you guys try them on your own. Because you guys need some practice and my voice needs a break. So for B, x equals 10 to the y power. Get y by itself. For C, x equals log base 6 of y plus 1, get y by itself. For D, x equals 5 to the 2y power, get y by itself. Oh, sorry, say again. You're swapping and then isolating y. Correct. Okay, so how would you get y by itself for part B? What would y equal? Because it's right now it's an exponential equation. to undo the exponential equation, you have to rise a log. Remember, why do we have logs in the first place? To isolate exponents. So it's log base what of what? What's your base of the exponent? Or the power, that's the right way of saying it. And it'll be x. There we go. Yep. Let's look at C. Now that's a log equation, just like part A. To undo the log, you have to rise an exponential equation. What's the base of the log for C?
6,
So how do I undo it?
y equals 6 to the x plus 1.
Six
Log 6.
six to the x equals y plus 1. And y be 6 to the x minus 1. And then lastly, for this one, you're going to rise log base 5 of x equals 2y. So y will be log base 5x over 2. Correct. Yes. X is the input of log. It's in parentheses, actually.
So it should.
Yeah, so that's how we. And now, if you want to do,
Like Emerson, you're talking about how you want to like talk about the steps, right? Like let's list the steps and do them in reverse order, and we do inverse. You mentioned the other day, right? So let's think about for C, right? What does x see first? +1. And afterwards do a log. Now, what's the opposite of log? Exponent, right? What's the opposite of adding 1? Subtraction. But if you reverse the order, instead of adding 1 first, let's take care of this first. So this comes 6 to the x. And then subtract 1 afterwards to get that. Here, you have 5 raised to 2x. What's the first thing x sees? The 2, right? What's the opposite multiplied by 2? Divide by 2. But also you see a 5 is an exponent. So that should go south of exponents, logs. So you log base 5 of x, then divide by 2. So if the multiplication is first, its opposite operation becomes, or its inverse operation becomes second. So, or last. So that becomes divide by 2 last, but log base 5 is first. So you can think of it like that as well.
that like reverse order of operations. All right. Finally, I know, very exciting stuff. Okay, it's 572. I'm gonna throw up the answers and kind of tell you what's happening. I'll just throw up the answers and I'll tell you why these work the way they do. Not
For like Z.
well, not quite. It's more this. If you just think about it,
7 raised to what power gets me 49? 7 to the second gets me 49. 3 to what power gets me 81?
4.
3 to 4, yes. 5 to the 7 gets me 5 to the 7. 10 to the 1.2 equals 10 to the 1.2. And 2 to the w plus 3 equals 2 to the w plus 3.
So the number that we write after like past the yield that equals, that's the exponent.
correct. Yep. It's almost like the base and the input kind of knock each other out, and the exponent becomes your answer. So, okay. So homework, we'll explore some more detail on Friday. Homework is just homework number 4. These problems just right up in Schoology. So you can work on it, hopefully get it done. We got 23 minutes if you want to do that, or stay behind for office hours for a little bit if you want to knock your homeworks. And that's all. I'm done. Easy Wednesday afternoon. Let me stop the recording. Call on Sam.